first of all, last class we talked about percent increases and decreases, discounts, markups, service charges, stuff like that. Anybody have any questions on any of those problems out of the packet? Well, there is a quiz that I will give you at the end of the hour. At the end of class, I say we got an hour and 20 minutes today. But I'll give you that quiz towards the end so that you can work on it, and you can either work on it and turn it in, or you can take it home and bring it back next time I see you. Actually, technically take it home and submit it because I won't see you guys till next Monday. Anyway, our next topic is to talk more about these proportions. We've talked about the ratio and proportion. Introduce us to percent is just an application of ratio and proportion. Well, we've looked at ratio as being a comparison of two numbers, like gear ratios and slopes and pitches and all that, but it can be more complicated than that. If I ask you to simplify a ratio, we've looked at things like 18 inches compared to 30 inches. Simplify that, of course, the inches cancel out. We can cancel out the units. What number can both of those be divided by? 3 works. 18 divided by 3 is 6. 30 divided by 3 is 10. Is that it?
No.
No, I can still divide by 2. 6 divided by 2 is 3, and 10 divided by 2. That ratio reduced to 3/5. Simplifies to 3/5. But what if we have 2 feet 6 inches compared to 1 foot 3 inches? Simplify that. We need to get everything into a single unit. Most likely going to turn them into all inches. 2 feet 6 inches. How do I turn that into all inches?
Does this mean you wanted us to reduce the stuff on the quiz?
I'm okay if you don't reduce it. 2 times 12 is 24. Plus the 6 that we already have is 30 inches. It's really the same process as having like 5 1/3 is a mixed number and turning it into an improper fraction. 5 times 3 plus 1. Same here. You do your feet times 12 plus whatever your inches are. This is 30 inches on top. We do the same on bottom. That is 1 foot 3 inches.
50.
There you go. But 1 times 12 is 12. 12 plus 3 is 50. Now, of course, to reduce that, inches cancel out. What can both 30 and 15 be divided by?
15.
5 or 15 works. 15 is a little bit bigger. 5 would have worked, but we can do it all in one step. 30 divided by 15? 2. And 15 divided by 15? 1. Now, of course, we can't take that as just 2. We have to leave it as 2 to 1 to be a ratio. It has to compare at least 2 numbers. In your notes, I want you to reduce 3 feet 4 inches and 1 foot 2 feet 1 inch. That ratio. Simplify that ratio. So, how many inches? 3 foot 4 inches is how many inches? 40 inches. 2 foot 1 inch is 5. Of course, the inches cancel out, and both of those can be reduced by 5. 40 divided by 5? 8. 25 divided by 5? 5. That's an 8:5 ratio. There are going to be times where we need not just two numbers compared, but three or more numbers compared to each other to make a more complex ratio. We might have 28 inches to 21 inches to 35 inches, the ratio. Could be a box, length, width, and height, or anything that has three dimensions that has to stay proportional. Now I can reduce this ratio. Again, all three numbers have to have the same units. They're all inches. So we can cancel out the inches. It looks a little different than our fractions, but we can still reduce it. What can all three of those numbers be divided by? 7. So 28 divided by 7? 4. 3. 1 divided by 7 is 3, and 35 divided by 7 is 5. That is a 4 to 3 to 5 ratio. Like I said, that could be a box. It has to be 4 by 3 by 5. Length, width, height ratio. Or one of the more, in construction, one of the more common three-part ratios, mortar mixing. And when we mix mortar, there are actually 4 ingredients, but the 3 solid ingredients we have the Portland cement, often just referred to as cement. We have lime, and we have sand. The different types of mortar have different purposes and different ratios of mixing. We have type M mortar. Type M mortar is a very flexible mortar. It's for applications that are going to have a lot of vibrations, a lot of movement, so it doesn't crack. It's strong, slightly flexible, but extremely expensive. Type M mortar is 4 parts of cement to every 1 part of lime to every 12 parts of sand. So way more Portland cement than there is lime. Lime is it's a little bit sticky, but it's very brittle, and it's kind of a filler to make the Portland cement go a little further. There's type S mortar, which is kind of an all-purpose mortar. Still has some flexibility, but it's not quite as expensive as type M, because it uses Portland cement as the expensive part of the mix. It uses 2 parts Portland cement, so 1 part lime, to 9 parts of sand. As we keep going, we have type N. Type N is the most commonly used type of mortar. Type N is 1 part cement, 1 part lime, to 6 parts of sand. Notice, by the way, in all of these, if you take the parts of lime and the parts of Portland and add them together, the amount of sand is approximately 3 times that. For type M, it's a little less, but that's usually typical, is to take the amount of all the other solid ingredients and you multiply by 3. That's how much sand you need. Finally, we have type O. Type O is used for temporary structures. If you have something you're going to build it and you're going to tear it back down again, you'd use type O. 1 part of Portland, 2 parts lime, 9 parts sand. Notice there's a lot of lime. So it's not going to be very flexible. It really can only handle loads on top of it, direct top loads, not any side shear loads or anything like that. Anyway, those are our ratios.
So wouldn't N be the most,
Well, O is the weakest because it's got the most lime in it.
okay, so lime significantly detracts.
Yes.
Okay.
It takes away from the flexibility and it takes something away from the strength. N is the most common because it's still strong enough, but it's has higher, a little bit more lime. Yeah, M is by far the strongest. because it has the Portland in it. Strongest and most flexible, but it's expensive.
So what would the standard Quikrete be?
What's that?
The standard Quikrete, what would that be?
That's cool. It's usually somewhere between N and O. It's got a lot of lime in it. That's why Quikrete is so. If you try to like pour a sidewalk off of Quikrete, it'll bust up. It's very, very weak. If you're gonna do anything like that, you get like a vertical patch or something. A vertical patch is somewhere between N and S as far as the Portland content. And that's usually, it's expensive, but it's a little bit more durable. The problem with O and N, if you're going to use it on exposed surfaces, N is pretty good if you seal the mortar lines. The higher the lime ratio, the higher the amount of lime, the more likely it is that the lime is going to leach out when it gets wet. So the type M is also the more long-term, more durable, because the lime can leach out, but the Portland's still there to hold it together. Whereas with type O, if that lime leaches out, you've lost 2/3 of your mortar pretty much.
Which version would you guess that they used on the exterior of this building?
Probably N. I always like this exposed brick wall here. If you look at their mortar lines, I mean, it's a commercial job, but boy, I would have gone nuts if my crew had done those mortar lines. I would have been screaming at. Because you can see they go like this on the horizontal ones, and the vertical ones do not even come close to lining up. Now, a couple things I want to pass out to you here quick. Well, the first thing you notice, there's a lot of spots where the mortar, the grout line on.
There's a couple of them that look like the gaps are about a 1/4 inch bigger than the other one.
Yeah. And you look at the grout line, the mortar line should be in the middle of the brick above it.
Yeah.
And there's spots where it's nowhere close to the middle. It's way off to one side.
I got a few over here, but what I really see is that you got the mortars all over the surface of the brick right here.
Well, that's not mortar. That was what they screwed up when they painted.
Oh, why are they painting the brick? Wait a second, you're giving us papers?
I am.
Are they COVID clean?
They're clean by COVID, yes.
After they go home or get lost on the floor of your car for 2 weeks and you find them, they should be clean by then.
Yeah.
Sorry.
One more try. He's a slow boat.
Is that all that she? Yeah, that's all she did. That's it.
So I passed up 2 packets here. The first packet is on ratio and proportion. It's just more practice with these more complex ratios. In that packet again, just do the gray boxes. I don't think there's too many in the middle of this one. There's maybe one extra one. As you flip through, you can see like on the bottom of page 98, there's a gray box. There's some problems there of reducing ratios. Then I think it's all the way to the end. You gotta go to page 104, there's another gray box with some proportion problems to do. The other packet here we're gonna work on together right now. This is mortar mixing. Now the table given here, the ratio by volume is the same table I gave you in your notes. It's just they have fractions instead of whole numbers. But it's still, for type M, 4:1 ratio of Portland to lime. But the nice thing about this table is you look at that far right side, it has the quantity per cubic foot.
FX.
Yes.
Yes, different.
What's that?
Your M&S.
M&S, no, they're the same. They just have 1 to 1/4 instead of 4:1, but it's the same ratio.
No, I mean, I'm saying, you got 4.5 and 3.
Yeah, but multiply by, everything for M, everything I put up there is multiplied by 4.
Oh.
And for S, everything's multiplied by 2 to get rid of the fractions. So the first thing you'll notice is for type M, they have 0.29 for the quantity of Portland, 0.07 for the quantity of sand. Is that 4 to 1? Not sand, lime, I should say. No, it's not. The reason being is, and if you add all those up, by the way, sand is 0.87. If you add all those up, you come out to like, what is it, 1.24, 1.25, or 1.23, I guess. That is way bigger than 1. How can you have 0.87 cubic feet of sand added to 0.07 cubic feet of lime added to 0.29 cubic feet of cement?
It's not a
That's
percentage,
one
it's a
cubic
ratio.
Well, it's a portion. That's 1.29 cubic feet of cement.
It's not a percentage, it's a ratio though.
Yeah, but it still should add up to the whole volume.
Should add to 100.
Should add up to 1
Or
cubic
1.
foot, right? Because this is per cubic foot.
It looks like it's crap.
144
What's that?
inches. Cubic foot's 144 inches. Or I think,
No, 1 cubic foot. Well, it is, but this is not inches. This is a 0.29 cubic feet, is what that's saying. The reason it doesn't add up is if we look at sand, sand actually has fairly large grains in it. Are those bigger anyway? So if you look at the sand there, when you have a bucket of sand or wheelbarrow of sand, whatever, there's a lot of air in it. There's gaps between the particles of sand. Both cement and lime, cement's actually even finer than the lime, but their particles are smaller than particles of sand. In fact, especially the cement, it's actually small enough that it fits between the particles of sand. I can take a bucket of sand, I can add a couple of handfuls of Portland cement, and of course it's going to stack on top first, but if I shake it, eventually that Portland cement will filter down through the sand into the gaps and it won't add any volume to the sand at all. So I can add, there's a certain amount of Portland cement that I can add to sand without adding any volume to it because it fits in between gaps. And the same does with the lime. Lime will fit in between some of the gaps as well. I mean, still there's going to be more than what fits in the gap, so it does increase the volume some. But if I take 1 cubic foot of sand and add half a cubic foot of Portland cement to it, I'm not going to get a total of 1.5 cubic feet. I'm going to get like 1.3 cubic feet. Kind of a weird thing. You'd think if you add 1 cubic foot and half a cubic foot, you get 1.5 cubic feet. It doesn't because of the gaps between particles. So that is why these numbers are not going to add up to be 1 cubic foot.
All 4 of them have.
No, they won't, because it's different ratios of the Portland and stuff. Like for the type S, it's supposed to be 2 to 1. It's just 0.21 to 10 to 0.94. That one adds up. That's actually, this was 1.23, this was 1.24. 5 actually. And 0.16, 0.16, 0.96. That adds up to 1.28. Then 0.10, 0.21, and 0.95. So what this means, let's say that we need 8 cubic feet of type S mortar. Amount of Portland cement we're going to need. Let's put some. 8 cubic feet times, what's the number for type S for Portland or for cement?
0.21.
0.21. 8 cubic feet times 0.21. 1.68, right? Cubic feet. For lime, 8 cubic feet times, what's the number? 0.1. That is 0.8 cubic feet. Lime. Sand. Take my 8 cubic feet times 4. Which gives me, what, 7.52, I believe, cubic feet? Does that look right? That's how much I need of each of those pieces to mix together to make 8 cubic feet type S mortar. Now I said there was 4 components. The 4th component is water. You just add water to resistance. There are some areas where building codes requires a regulated amount of water, but unfortunately, to calculate the regulated amount of water you put into your mortar, you actually have to test the moisture content of your sand and adjust the water according to the moisture content. We're not getting into that. I don't hate you guys that much. I won't make you do that.
Thank you.
That's your motivation not to upset me throughout the semester, right? In your notes, I want you to find the amount of each. If we are going to use for, let's say we need 19 cubic feet mortar. Type, we go type M mortar. So for cement, it's going to be your 19 cubic feet times, what's the factor for cement? 0.29. What does that give us? 5.51 cubic feet of cement. For lime, it's going to be 19 cubic feet times
0.07.
0.07. What is that? 1.33. And for sand, it'll be 19 times 0.87, which gives us 0.87. That's the first step, is once you know the amount of mortar, knowing how much of each ingredient for mixing that mortar. So we're going to slowly work backwards here. The next question is, how do we know how much mortar we need? Well, there are tables that allow us to do this. We go over to the next page, page 92. First of all, on the top of page 92, there's 5 problems there that'll ask you to do exactly what we just did. Only, there's a little catch. Notice they're not labeled cubic feet for A, B, and C. It's bags of Portland cement. 1 bag, depending on where you're purchasing it, 1 bag is either half a cubic foot, like at Menards, or if you're buying it from a supply store, contractor supply, contractor bags are 1 cubic foot per bag. So figure 1 bag equals 1 cubic foot. So for both the cement and the lime, they're asking for bags, that's just asking for cubic feet. For sand, however, part C, they're asking for cubic yards. We got 16.53 cubic feet. How would I change that to cubic yards? Where did the 27 come from? Yeah, it's a cubic yard, so it's 1 yard, 3 feet, by 1 yard, which is 3 feet, by another yard. 27 cubic feet in a yard. 16.53 divided by 27 give us 0.612 cubic yards. So when you do that portion of the chart, make sure you are converting the sand into cubic yards. On the bottom of page 192, it has, and the top of page, bottom of page 92 and top of page 93, there's a table that has different sizes of brick. The size of brick used and the size of the mortar joint is what determines the type of mortar. Obviously, a 1/2-inch mortar joint is going to take more mortar than a 3/8-inch mortar joint. A smaller brick is going to take more mortar because there's more mortar lines between bricks. It's going to take more bricks, more mortar. Bigger bricks take less because there's more of it's taken up by the brick. The first thing we look at is the square feet of surface area covered. Anybody know the dimensions of a standard modular brick like the ones on the wall up here? Very close. They are 8 inches long. They are 4 inches deep. And they are 2 1/3, or not 2 1/3, 2 2/3 inches. That's actually the first one there. 4 by 2 2/3 by 8 is the.
They can make like a standard measure. 2 and 5/8.
Well, I use the word modular. The reason they are 2 2/3 inches is because they want it to come out at 2 feet going side to side. So that's the 8 inches, comes out at 2 feet. Technically, they say it's 8 inches long. It's actually like 7 5/8 inches long is what it really. 2 2/3 for height. If you multiply that by 3, it comes out to 8 inches. So again, it's going to come out at 2 feet going up as well. That's why they come up with those numbers. So it's modular at 2 feet. Other bricks, larger bricks, they try to make them modular at least at every 4 feet. So anyway, let's say I need to cover a wall, 450 square feet. I am going to use 4-inch by, let's use 4-inch by 4-inch by 12-inch brick. And with 1/2-inch mortar joint. If I look at my chart there, I find 4 by 4 by 12, which is about 2/3 of the way down on the bottom on page 92 there. If I slide over, it says bricks per 100 square feet. What's the number given there?
300.
300. It's 300 bricks. Per 100 square feet. So to find the number of bricks it takes here, I'm going to take my number of square feet, 450 that I gave, I'm gonna basically do a measurement conversion. It's gonna be times 300 bricks over 100 square feet. What happens here is the square feet are gonna cancel out. 450 times 300 is 135,000, right? Over 1 times 100 is 100. We divide that out. 1,350 bricks. I'm gonna pause there. Does everybody see how I did that calculation? Any questions on what I did there? My area times the 300 and then divided by the 100. 1,350 bricks for that. Leave a little space there, so I'm gonna have you guys try an example. We're gonna come back to the mortar. That's why I leave the space there. We're gonna come back. I'm gonna cover 725 square feet with 4 by 2 2/3 by 8 inch. And we're gonna do a 3/8 inch joint. Again, you don't need to know the joint, but you need to know size. Tell me how many bricks it's gonna take for that. So in your notes, figure out how many bricks that's gonna take. Hundred 75 bricks per 100 square feet, right? We're gonna take 725 times the 675, then of course, divided by the 100 square feet. Now we're gonna round up because you can't have 3/4 of a brick. 4,894 bricks you come up with?
Yeah.
Any questions on how I got the number of bricks? Now, let's go back to mortar. This one we said was a 1/2 inch mortar joint, right? So we go over on the far right side. This was the 4,412. For a 1/2 inch mortar joint, it says how much? 15.7. Now this is 15.7 cubic feet of mortar per 1,000 bricks. So once we have our number of bricks, 1,350 bricks, put it over 1, and we're going to multiply that by that 15.7 per 1,000. 1,350 times 15.7 divided by 1,000, we get 21 point, we're just going to go to 1 decimal place on our amount of mortar there, 21.2 cubic feet of mortar. That make sense? Questions on how I got that? For our example down here, with the 4 by 2 2/3 by 8 brick, we found we needed 4,894 bricks. With a 3/8 inch mortar joint, figure out how many cubic feet of mortar we will need there. We have about 1/2 minute to do that in your notes, then we'll go over it.
Really measure the joint to make sure.
That's a good question.
Because if you're running down a 20-foot wall and all of a sudden you're 1/2 a brick off.
They call it laying to the line. So they will have your, especially if you're on a bigger crew where there's like 3 or 4 masons working together, they'll have your more expert masons doing the corners. They will lay the corners, and their striking tool is set to be 3/8 of an inch wide if they're doing a 3/8 inch joint. So when they strike it, they can tell if the tool is fitting between the bricks, or if there's a gap, or if it's too tight or whatever. But they will put the corners up, and once they lay the corners, they'll call it a line. It actually clips onto the side of the block, and the string goes all the way down.
Yeah, that's decided like vertically though.
Yep. So going side to side, it's more of a guess on the part of the mason. They have to look down and make sure they're staying pretty. Now, when you look down at the top of the block, there's the cavities in the bricks, so they can see if they're right in the middle of that center cavity or not.
Oh, yeah.
Yeah, basically, the side to side is just a guess.
I was wondering if you start laying them, an eighth an inch, and all of a sudden it's 20 feet down the wall.
Oh, yeah, 6 bricks down, you're an inch and a half off.
Yeah.
Okay. It's not as easy as it looks.
I've never laid brick before.
So for the 4 by 2 2/3 by 8 with 3/8 inch joint, we have how many cubic feet?
39.
Oh, the first, the cross of the 8.1 cubic feet per 1,000 bricks again. Notice again, the bricks are going to cancel out. Yes, 4,894 times 8.1 divided by 1,000 give you, what was that? 39.64 cubic feet.
Yeah.
39.64, 39.7 cubic feet of mortar. Now, this goes back to what we talked about last Thursday. Waste factors. Mortar gets slopped around a lot on a job site. Now, this number here is just the mortar between bricks or blocks. I believe they do actually have, I guess they don't have a full-size block here as far as your 8 by 8 by 16 or anything like that. No. But if you actually are using cinder blocks for doing your walls, you actually have to fill, depending on building code and what's really, every 4th cavity or every 8th cavity has to be filled mortar and with a reinforcement rod in it. That's not figuring out that volume in this formula. You'd have to figure that out separately. But waste factor, you're slopping around on these bricks, it gets spilled on the ground, it gets spilled when you're mixing it. You strike it off. You know what I mean when I say strike it off? You look at those joints there, they got that nice little round, and you can take your thumb and run it through. That's actually how they used to do it, is they just take their thumb and strike it off. That tears the heck out of your thumb. So now they have a metal tool that they use it for. But when you put the mortar on there, it's sticking out a little bit. You strike it off, it gets peeled off, and basically it's flung on the ground. You don't reuse it. So there is a considerable waste. Usually we figure, what's that?
About 20?
Anywhere from 10 to 20%. Yep. We're going to say 15% for this example. So how do I add 15%? Well, I could find 15% and add it on, or I could just find 100% plus 15% is 115%, which is just multiplying by 1.15. So we could have our 39.64 times 1.15 is 45.59 about.
Yeah.
Mortar the region. What do you think? We having fun yet?
A lot better than online.
I'm not gonna lie, I enjoy this a lot more than I.
Yeah. Well, that's good. It's this stuff at least applies to what you're doing too, which I like.
So what's the waste factor?
We did not figure in the waste factor of the brick. That's a very good question. One of the biggest mistakes that's made in estimating, let's say you're going to have a 10% waste factor on the brick. They'll add the 10% waste factor to the brick. Then they'll use, because then there'd be like 500 more brick, it'd be like 5,300, what that come out to be. Well, then they use that to figure out the amount of mortar. Well, the waste factor on the brick is for breakage of brick. Or cut block, or you cut them and you can't reuse the piece you cut off. That doesn't increase the amount of mortar you use. So you find the amount of brick you're going to need, you figure out the mortar off of that, then you go back and you find your waste factor for your brick, whether it's 10% or 15%. Then you do that times 1.10 or 1.5 each number of brick. If you do that, if you do the waste factor on the brick and then use that for the mortar, now you've compounded your waste factors. You got way too much mortar.
If you did it once, you wouldn't count on it, would you?
What's that?
You just did it once. wouldn't
Well,
count
some
on it
people,
then.
what some people will do is they'll use the same waste factor for brick as they do mortar. So let's say they're gonna use 15% on the brick, which is a little high, you're not gonna break that many brick. You add 15% to the brick, and then once you get to the mortar, that already includes your 15% waste, you don't have to do it again.
Exactly, so why would you do it again?
The reason you do it is usually your waste factor on your brick is different than your waste factor on. Your mortar is usually a higher percent of waste than your brick. Unless you're really clumsy on the job site.
Oh, that's David.
Yep.
Had a rough go on the job site.
Even as a kid.
Yeah. I had one guy that worked for me once. It was just unreal. If there was a nail on the ground on the job site, he'd find a way to step on it and put it through the bottom of his shoe. I couldn't let him use a hammer because he'd whack his thumb every time. Just nuts.
David.
Yeah, that's you. I wouldn't put him anywhere near the edge of a roof because I don't know how many times I grabbed onto his work belt because I saw him going over the edge.
Jesus.
Not me, I don't get close to it.
Then he complained
You
because
don't
he was
even get on the roof.
Yeah.
then he complained because he was the one I always made when we were doing roofing. He was the one I always made go up and down the ladder and carry stuff because I didn't want him to be up on the roof. Bring it up the ladder and drop it on the edge of the roof. We'll get it from there. Yeah, I mean, I figure at least if he's on the ladder, he's closer to the ground as he falls. So we've got a wall here that's 8 feet high by 48 feet long. We're going to cover it with 4 by 2 by 12-inch brick with a 3/8-inch joint. Type N mortar. I want to know a brick I'm going to say bags, but of course we know that means cubic feet. Cement. And bags or cubic feet of lime. And cubic yards. We'll walk through this example together, and then I'm going to give you an example to work through on your own. First step here, find the area to be covered. How do I find that area?
Multiply.
48 feet times 8 feet is 94 square feet. That's our area. Second step is to find the number of bricks that are going to be used. So we have our area, 384 square feet. How do I turn that into a number of bricks?
5 by.
Yeah, so the 4, 2, and 12 at 600 bricks per square foot. You got it. Bricks per 100 square feet, I should say. Absolutely correct. Times 600 divided by 100. That give us 1,304 bricks. Once we have the 2,304 bricks, next step is going to be to find, I'm going to have you find the cubic feet of mortar, and then we will adjust from there. So we are doing a 3/8-inch joint, right?
Yeah.
So the 4, 2, 12 for a 3/8-inch joint, what is our factor? 10.8. So we start with the number of bricks, 2,304 bricks. Over 1. Times 10.8 is cubic feet per 1,000 bricks. You got it. So we take our number of bricks, the 2,304, times 10.8 divided by 1,000. $4.88. Go 24.9. I'd be okay with that. That's fine. I didn't ask you to do this in the instructions, but we are going to add 15% waste. How do I do that?
Multiply by
Times 1.15. 28.64. After waste. Now that we know we need 28.64 cubic feet of mortar, we find the amount of cement, taking 28.64 cubic feet times, what did I say, type N? Yes. Type N is going to be times 0.16, which gives us 4.58 cubic feet. Now for lime, I think our 28.64 cubic feet, it's still times 0.16, isn't it?
Yep.
4.58 cubic feet again. Sand, 28.64 cubic feet. Times what? 0.96, which gives us 7.49 cubic feet. Now we asked for the sand to be in what units? Yards. So we divide by 27, which gives us basically 1.02. Is that right?
Yeah.
One thing we need to do, but I don't do it until the end, is we need to add waste for the brick. We're going to do 10% waste for the brick. The reason I don't do it till the end is, like I explained before, I don't want us to use the wasted number of bricks for figuring out the mortar. So 1.10, we're going to end up using 2,534.4, so 2,535 brick. What do you think? Good stuff?
Yeah.
Put it on your own?
Yeah.
You can go with it.
What's the worst that could happen, right?
Get it wrong.
You get flustered, you start fiddling with your pencil, it flies in the air, stabs you in the eye.
I just get pissed off and don't do it.
I appreciate that. So you have a wall that is 8 feet by 128 feet. We are going to use 4 by 2 2/3 by 8-inch block. Half-inch mortar joint. type M mortar. Again, do plus 10% for the brick, plus 15% for the mortar. So find the brick, the cement, the lime, and the sand. We'll be still working. Whenever you're done. Look and see how this came out. If you're not done, that's fine. You can fill in the details as we go. See if you're on the right track. So our first step, of course, is to find the area. How do we do that? 8 times 128, which gives us 1,024. What's our second step?
Find the bricks per 100 square feet.
Find our number of brick. You got it. We take 1,024 square feet times our bricks per 100 square feet, which is 75. So 675 bricks per 100 square feet. What's that give us? 6,912 bricks. Now we're going to use that number in two different capacities. We're going to use it right now to find the mortar. Then we'll come back and we'll do the 10% waste for the number of bricks. Now we're going to find the mortar. How do we find the mortar? $1,912 bricks over 1 times 10.3 cubic feet per 912 times 10.3 divided by 1,000 is 71.19 cubic feet. Do I need me to slow down for a second while you catch up on the notes? Now here's where we add our waste. So what do we do here? 1.15 gives us sounds right. $1.87. Now you could have found the cement, the lime, and the sand each, and then did the 1.15 times each of them, but we just will do it once and be done with it. How do we find the amount of cement? $81.87 cubic feet times 0.29. You got it. Gives us 23.74, probably 24 bags of cement. For lime, 81.87 cubic feet times 7 gives us
5.7
cubic feet. Bags of lime. And 81.87 cubic feet times 0.87, which gives us
I don't know. 27 right away.
1.94 cubic feet. And then, of course, yes, you're right. We do divide by 27 right away. Give us 0.64 cubic yards. 0.65. Either way,
I rounded up.
we'll splurge for the extra 1/100th of a cubic yard of sand.
No, we're gonna be off. We're gonna be one brick short.
Now we need to go back for our brick and we need to adjust our brick. What do we need to do this number of brick here? 0.1, 110%. Gives us
1,600.
1,604 brick. I see all but 2 of you have the quiz already submitted, so that's great. Those of you that don't have it submitted, would you want me to give you a paper copy to do, or would you rather do it electronically and submit it later tonight? Want a paper copy? No? We'll do it later? So I have 2 packets for you to work on. In the ratio proportion packet, That's page 95 to, was it 106? Yes. Again, do the gray boxes in there. And then we have the mortar packet. Do that whole packet as well. Don't have the quiz done yet. Make sure you get that submitted later tonight, please.
Do I have it submitted?
Yours is not, no.
Oh, I finished it, I meant to submit it.
Okay, no problem. So I'm gonna have you guys do me a favor before we leave. I'm gonna have the back row, if you would stand up and pull that table, that line of tables back like 3 feet. There you go. Then the middle row, if you guys would stand back or slide back and pull your table back about 1.5 or 2 feet. Front row, stay where you're at. Yeah.
I gotta move that way, like-
Oh, I might be an inch off.
You guys are good right where you're at. Otherwise, it gets, if you guys get any closer, it's really hard to see the screen because it's right where it is. So there you go. Okay, so with that, if you guys want to hang around and work on